Hello guys, good morning. Welcome to another episode of XR Talk Show. So today we are going to continue doing the Advent of Code, live coding day 5 in Wolfram language. Then after that, I'm going to do a efficient stack, implement a efficient stack data structure in Python, in JavaScript, and if we have time, we're gonna do it in Wolfram language, and we're gonna time it. So I'm going to finally resolve the issue of whether the Python's smart array, Python, Ruby, JavaScript, they all have a array or list type that grows as you add more items. So we are going to test to see if that data structure is a efficient stack, versus our own implementation using linked list. So that is what we're gonna do. So yesterday we did 2 hours, Advent of Code day 5. Yesterday we did 2 hours Advent of Code day 5. And I went into a tangent about how do you implement a efficient stack in functional programming languages. Okay, so today we're gonna just quickly finish the Advent of Code day 5. Then we're gonna do the stack. Okay, lots of to do. So if you like my stuff, pay me. Okay, donate, Patreon, PayPal on my website. You will see, and happy to see your comment. Okay. So here is my coffee. Ready to code. Begin. Coffee with milk, coffee powder, and honey. This is apple juice. And this is tea. I'm ready to code. Serious stuff. And the tea. Okay, I'm gonna blast through the Advent of Code yesterday. So let's begin. So start a Wolfram language code and go to the talk show, and the pink window shows all my XRFly keys, command names, and the keystroke. I'm using Expose keyboard, and I'm using XRFly keys with Vorak layout. This is Expose. I recommend it. Okay, so day 5. Let's show day 5. Day 5 yesterday. So we need to get the problem input. Okay, so let's copy that. Let's just quickly do it, finish it. It should be in 20 minutes, okay? So, wait. What are we doing? Okay, copy that. Go here, today's talk show, and post the link to yesterday so we can easily access it. And then Wolfram language, we need the code from yesterday. Okay, that's not it. Okay, I think that's it. Yeah, let's copy that. Okay, so paste the code here, remove that, and pop it out. Okay, let's begin from yesterday. So the problem, to recap, the problem is that you are given this input. The first part shows 3 stacks like in stack of books. It's a data structure. So you are given that input, and you want to move one item from stack 2 to stack 1. So stack 2 is MCD, so you move the D to stack 1 to over here. Then the second thing you want to do is move 3 from 1 to 3. So stack 1 is here. Then each time you can only move the topmost item. So you do these 3 times. Then you do this one. Then you do this one. The problem is to find out at the end what is the result. What's the topmost letter? Okay. So that is the input. So first of all, we gonna rewrite this. We did yesterday. So now after a day, I have much more better way. Okay, so string input, split that into, first of all, we want to split this string into 2 parts. The first part is the actual input of the configuration of the stacks. The second part is the procedure, okay? So split, then this is lines of stack with lines of stack config. Okay, let's go elaborate in the naming of things. Okay, so then you split by the line ending character. So you get, first of all, you split this string into 2 parts, the first part and the second part. Then you get the lines of stack config. You do it by split with end of line. So each line, you got a list of strings. Each string is a line like that. Okay. Then here, string split again of x1, which is the list of lines. What? Okay. Let me do this. Okay. Good morning, Greg and Doc. Okay. So string split x1 is list of lines. Then we string split x1 the first part. So this becomes a list of 2 strings, a list of 2 string blocks. Okay, so this is the first part of the string. We split it by a line character. Then we get the list of lines, which is the stack configuration. Then the second part of x1, which is the procedural part in English, we split by, so we got the list of lines. Procedure, let's see, lines, okay? List of lines. Then we want to get the total count of columns. So you can do that easily by get the last item of the lines of stack config, the last item, which is the last row. Then you take then you split string split it by a space. So you got a list of strings. Each string is 1, 2, 3, and so on. Okay, so then you take the last one of that, which is 3. Then you to expression, you turn that into a number, string to number. So you get the column count. Okay, then this line is a bit complex. Let's redo it so it's much more simpler. Okay, let's say so let me do that. String partition. Okay, x2 equals to, so the x lines is actually lines of config. Okay, so you want to let me simplify this. Okay, string partition. Okay, this is incorrect. Okay, let me do this. lines of stack config, which is the list of lines here, what you want to do is you want to pad it. Yeah, you want to pad it so that, you know, you want to pad extra space, like add space, so that later on you can chunk it by every 4 characters. Then you get a list of rows of the crates. Then you do a transpose, so columns becomes rows. So each row represents a stack, you know, which is the original vertical lines. Okay. So you want to string pad here is the, let's write this. So right now you want to pad the string. So what you do is you want to map. That's right. Okay, so that's column count. Then what you want to do, you want to pad it. Okay, so map, forget about that. Maps takes 2 arguments. The first part is a function, the second part is a list. So you want to map this, you pad it here. So map string pad right arguments, and so here's a function. That ampersand stand is a shortcut for function, so this is a function. So you want to map this function. Let's do this. You might want to map this function to this list of lines, and this function will just pad right. By how much? By to make sure that there is number of columns count times 4. 4 because each of a crate is 1, 2, 3, 4. 4 characters. We want to do that because so later on, you know, this empty, we have things to work with. So x2 is pad, then you want to then you partition it. Okay, that is, given a string, you want to separate the string into a list of items. Each one is a string. How do you separate them? By every 4 characters. Okay, so that is the string partition, this function. Okay, takes 2 arguments. The first argument is the string, the second argument is how many, you know, how many characters you want to chunk. So yeah, so the first argument is a string partition, is a string, so x2, right? Oh, then you need to map actually. So because you have again a function and x2. X2 is a list, padded list. Okay, so let's rename it. Let's just x2. Okay, so x2 is a padded list. Then we partition it for each of these line. We partition it by every 4 characters. Okay. Then we want to do a trim. So let's say x4. We want to do a trim because you see these 4 characters, then there's a space at the end, right? So we want to trim it. And we also want to remove the square brackets. Okay, so x4 is trim, so you need a function here. This will be string trim. Okay, string trim takes 2 arguments. No, string trim, we just need to trim it, that's all. So once you trim it, then to every line, a list of lines, once you trim it, so each item is like that, a string. So you want to replace, string replace, okay? You want to string replace here a function, you map, so we don't need the trim here. So we'll simplify the code later, but now we want to focus on the clarity of what's going on. So you want to string replace of the left bracket by nothing, right bracket by nothing, and applies to x4. Right? Okay, here it should be x3. Okay, so okay, so far so good. Yeah, so in fact, let's show it. Let's show some Wolfram language code. Paste it here. Okay, so that's the code. Evaluate it. Okay, we got something wrong. String partition, string expected. We can finish this in 30 minutes for sure. So something wrong there. So let's double check. Wait, what is the string partition? Okay, string partition is wrong. Where did here? So string pad right. We add, we make sure there are each line of the crates string has this number of characters. Then we string partition. Oh yeah, so this string partition here, this needs this part, the first argument needs to be a function, remember? So the function, since you are using the ampersand whatever previous, makes that a function, a lambda function, and the pound sign is a shortcut to stand for the argument. So this string partition is a function. Okay, yeah, so now let's do it again. Copy it, paste, run it. That's what we want. You see, now we do have empty elements. For example, output 19, show it in input form. Okay, slash is a, like the Unix pipe, it's a postfix notation. So you see we got empty strings, so we need to remove that. Okay, so x6, remove the empty string. So again, you need to map, and what is a function you need to use. You don't need the parentheses. So you want to delete cases. Okay, delete cases, take a list. Okay, take a list, so that is our argument for each of the line. Then what do you want to delete? Empty string. Okay, that will delete it. And let's try it. So here should be x5. Fantastic. Okay, now once we delete, so far this represents the stack, and we need to remove that 1 2 3, because you know that is just an indicator. So x7, Okay, so actually, so don't need that. So drop takes two arguments. The first argument is the argument, is a list, and you want to drop the first item. Okay, so that's how you do it. Oh, you want to drop the last item, so not first. So let's do it again. Fantastic. This represents the stack NZDCM. Oh, we forgot the step. We forgot the. Yeah, so right now they are rows. They are, so you can see ZMP. We forgot to do the transposition. So we need to do the transposition before we do the delete cases, the empty string. So so I think you do the transposition. Transpose, okay, not plot range. Transpose, okay. Yeah, so you just say, let's put it here so that we don't have to change all the variable. So transpose takes a square matrix, which is a list of lists. Then rows becomes columns, okay? So let's try that. X3. That's right, you see, that is what we want. And now you can remove all the brackets, okay? Then you delete cases. You remove the empty lines. Then you want to drop the last item, okay? So in fact, we can drop the last item before we do transpose. So here. So here we want to add a function here and apply it to that. So the function will be this drop. Okay, add ampersand to make a function, and pound sign stand for the argument. So this line, it works like you map string trim to x3, then you apply this function drop to drop the row 1, 2, 3, then you do transpose. Okay, so let's test that. That's right, you see NZDCMP, yeah. So and now we remove the brackets. Okay, remove the brackets, and now we delete the cases empty string. Okay, so basically so what is this? X4, so X5 and X6. Try it. Fantastic. NZDCMP. So we got our stack. Okay, so let's shrink the lines. Okay, so that's a bunch of lines. We don't need, we can make it into one line like yesterday, but let's not. So remove that. So now we need to apply this English procedure to our stack. So what we can do is first of all, we extract, we remove the move from to, things like that, remove them. So we just want a list of numbers, okay? So 1, 2, 1, 3, 1, 3, 2, 2, 1, 1, 1, 2, things like that. So first of all, string replace, okay, takes two arguments. The first argument is the meat. The second argument is how you want it to replace. So we want to replace by, okay, let's just type it. So we want to replace move space to empty string. Okay, that's one thing. Then second thing, third thing. The second thing is gonna be from space, okay, to empty. Then space to empty. Okay, so let's see, let's say x7. Okay, oh, and what is yeah, so let's try it. Fantastic. x7 pipe it to input form, so we can see the quote. There it is. Okay, so actually we should leave the space so that we can string split. Yeah, let's leave the space. Okay, leave one space. So move, so we want to remove the move space. Yeah, then from, okay, then let's do that. Okay, let's try it again. Okay, that's you know, that's so for example, any guys watching? Comments. Okay, so we got that. Very nice. 1 to 1. Yeah, very nice. Now we just do x8 equals to we want to split string again. Okay, 2 arguments. The first one is x7. And how do you want to split? You just want to split by space. By default, that is split by space. Okay, so we got a list of lists. So each one of the element, the sublist, represents a procedure. Okay. So for example, let's take the first one, 1 to 1. You know, this line 1 to 1. So that means pop from stack 2, pop one item out, then add that item to stack number 1, and do this 1 times. Okay. Okay, so x8 will be, let's name them procedure gist. Okay, so that's just a list of numbers. You know, it's a list of 3 numbers. Now we are going to write a function that takes this list of 3 numbers as input. Then we just apply this function to our stack, you know, to the stacks we created there. Then we got the result. Okay, let's write a procedure. The procedure is gonna be something like that we did yesterday. So in Python, it's very easy, but because Wolfram language do not have drop and push for a list, so let me explain this one. Okay, so yesterday we did, let's see, Python. So for example, here is an example in Python. All you have to do for x in range 1 to p, p is the first, how many times move, you know, to do it. So for range x in a to 1 to p, you just stack list n dot push, then stack list m dot pop. So, you know, here is a move p number of times from m to n. So in Python, that's what you have to do. So you just write a function that takes p, m, n. Okay, so we are going to do the same thing, but in Wolfram language, pop, let me write this out. Okay, I already written yesterday. So push and pop in Wolfram language. Now, there's no direct analog of push and pop. By the way, pop means takes a list. Pop that list means return the first element of the list, but also drop that element from the list in the variable and save in the variable. So there's no direct analog in Wolfram language of pop. However, what you do is you do first that extract the first element, then you call drop that remove the first element in a list, then you call set. Because Wolfram language is a functional language, so whenever you do something to a list, it doesn't change nothing. If you want to change the list variable that stores the list, you have to reset it back to the list, just like Lisp. Lisp also works this way, except in Lisp you do have push and pop because Lisp is based on linked list. So in Wolfram language you don't have that. So the operation pop is equivalent to these three operations. That's why yesterday we went into a tangent about 90 minutes on how to implement stack efficiently. Now the way I'm going to do it here now is not efficient, meaning that if you have 1 million stacks, each stack has 1 million items. So when you have that situation in real life, process Twitter, input up, that's not efficient. But for this toy problem, even 10,000 input, 10,000 stacks, that's not a problem. It's gonna be done in 1 second. Okay, but so let's just quickly finish this. Then we go on to about implementing a efficient stack in Python, in JavaScript, in Wolfram language to see there's any actual difference. How many stack items, let's say 1 million, does it actually make a difference? Let's check. Okay, but first of all, let's write this simple thing. So in order to do this in one step, if we're gonna do this, so move p number of items from stack m to stack n. Okay, I don't like the m and n because they let's change, should we? Let's use m and n, mountain and no. So far so good. How is going, Greg and Doc? Where are you from, Greg and Doc? Report age, sex, location. So I get to know you, roughly you are teen, you are 20 something, you are 30 something, you are probably young people. You are probably a young guy. Apple juice. And tea, okay? Fantastic. Okay. Procedure numbers. Okay, let's name that procedure numbers. So this is, let's document it. Let's document a little bit so that people watching this kind of have a sense. Okay, and x7, let's say, what is x7? X7 is like that. Okay, let's copy that. So people know what's going on here. Yeah, and x6, let's do x6. Okay, copy that so it's clear. Okay, so that's x6 is stacks, x7 is the list of strings, then procedure numbers x8 is this. Okay, then we write a function. Yeah, so what the function do, so you first item is you take the first item of list of stacks of m, then for the list of stacks of m, mth stack, you drop it. Yeah, you drop it, drop the first item, then assign it back. And for the nth item, you prepend, which is push. Okay, you push the first item, so the first item can, you don't need a variable there, so well, let's just write it. You don't need a variable there, so but you need to reverse the order. You need to do this first. Okay, so we getting, hope you guys see what I'm doing. So you see, that's kind of simpler. So for the stack n, you have to assign it by prepending it an item from m, the first item. Then for the stack m, you drop the first item. Okay, so that is what you have to do. And you have to do this p times. Okay, so now let's write a function that takes the argument n m p just to do this. Okay, so how do you call this? Move. Okay, let's just say move. Okay, move, f move, that's a function. So the function body will basically be that. Okay, f move. Okay, something like that. So f move takes 3 arguments. Okay, p m n. Okay. Now, by the way, this is a procedural programming style, which is not recommended in Wolfram language. You know, this do, whenever you typically you never use do. So I can do it. I can use a functional style to do this. But let's push on. We don't want to end up 3 hours. So this function is using pattern matching. So this definition means whenever Wolfram language sees something like that, fmove, square bracket, curly braces, then 3 items, then it will automatically replace that symbolic sequence by this symbolic sequence and execute that symbolic sequence. This is what term rewriting means. Or in Lisp, if you are familiar with Lisp, this is if you are familiar with this is a macro. This is actually a Lisp macro. Lisp people don't know, but this is in fact is a Lisp macro. Okay, a very simple one, just like Lisp. Okay, so but okay, so when you define a pattern like that, usually you want to say clear, because you might have defined other macros or other rules for the f move. So when you define this, it doesn't override whatever previous, it just adds another rule. So that's why it's always a good idea to do a clear first when you use a pattern to define a function. Okay, So let's double check one more time. Where is our list of stacks? Let's see. Yeah, so where so list of stacks. Yeah, so let's name this x6 is a list of stacks. Okay, so that's our list of stacks. That's right. Okay, then once we define this function, all we have to do is call it. We want to x answer, okay, equals to map a function. What do you want to map it to? You want to map to this list of procedure numbers. Okay, that's a list of numbers like that. Oh, actually it's a string, so let's change those string into a number. So all you have to do is say toExpression. Okay, toExpression, then we put this inside. Okay, but you know, but there's a simpler way to do that. You can just say add sign. Remember, add sign is a syntactical shortcut. So instead of writing f square bracket something, you can just say f add something. 100%, it's a syntactical shortcut in Wolfram language. Now in classic Lisp, McCarthy's Lisp, he have the idea. This syntactical shortcut, he calls it meta expression, or MEXP. That's the original John McCarthy's Lisp. It's called meta expression. Look up on Wikipedia, you'll find it. Okay, so Wolfram language is the actual Lisp that implemented that language, this meta expression. The other Lisp didn't do this. They just have reader macros, which is somewhat similar, but in much smaller scale. So we can do that. Okay, so let's evaluate this again so we can actually see it. Okay, now let's try x8. Okay, now input form, so you can actually see they are numbers because you don't see the double quote. Okay, so now copy that and put it here. So it's no longer a string, it's actual numbers. Okay, delete that. Okay, so procedural numbers, you want to map a function to these procedural numbers. And what this function, the function is fmove. Okay, I think that's it. So let's try this. Let's just try this part. Incorrect. Path specification, list of stacks. Did we oh yeah, we didn't define it. That's right. List of stacks. You see, we renamed our x8, so now we have to do it. So let's do it. Copy it, paste here, run it. Do. So far so good, fantastic. And let me show you an extra trick. You see this input, you see this cell, you know, this code, we can make it look prettier. You see, now notice this right arrow, dash greater than equal sign. We can prettify that, it will become an arrow, and also things like this double square bracket. Okay, so let me do it. Control-Shift-N. There it is. Now this is another reformat. Okay, too bad it changed that into, you know, it changed this part into that. But however, you see, now this means the first part, the first element of x1. This means the second element, you see, and the arrows becomes arrows. Now if you have square roots or square or third power or square root, nested square root, they become, mathematical formula or integration, or, pretty. Okay, and also see the numbers, the number sign, the pound sign, the hash sign, they become hash 1 because the hash is equivalent to hash 1, which stands for the first argument. So if you have a function of 2 arguments, then you can say hash 1, hash 2 in whatever order. You see, remember this ampersand is a shortcut to represent a function. The full form of writing a function. Let me show you, okay? Let's say we want to write function of adding 1, okay? So first of all, one variable x and return x plus 1, okay? That's how you write a function. Then you can assign it by f something, okay? Now, there's a shortcut for that. You can just say, let me do it, okay? There, that's a shortcut. You see, the pound sign stands for the argument. And so this means the argument plus 1. And that ampersand just means whatever previous is a function. So you can put the paren there, but it's not necessary because the operator precedence, the equal has a lower precedence. So this will become one thing. Then you assign that thing to f. Okay, that's a explanation of the shortcut. There are many more, but I'm not gonna go over. I have the. Okay, for those of you interested, just go to Wolfram language tutorial. You can find it by searching. Then you can see all syntax shortcuts, or in Lisp jargon, the meta expression of Wolfram language. You can see all of them by here. Okay, so advanced symbol principles syntax, there you click on that. I did a full video talk on that, so you can see explanation of you see every possible syntactical shortcut, also known as meta expression, is listed here. So you can see all of them. So for example, the percent sign actually stands for out. Out is like a function, takes one argument, a number. So out -1 means the last output. 2% sign is a shortcut for out -2. Very convenient. So again, if you go back, you see every input output is numbered. So this output is not just a display. It is actually assigned to a function out square bracket 24. That's the Wolfram language. Okay, so before we were talking about function, you see the / is a postfix notation. So when you have x//f, that stands for f square bracket x. Okay, so you have the postfix notation, just like the Unix pipe. You also have a prefix notation, the @ sign. Then you have the /@ which is equivalent, 100% equivalent to the map fx. And before we talked about function, so you also have function composition. For example, before we talked about function, you see the ampersand sign. Let's magnify. You see prefix, postfix, you also have infix, then you have the pound sign standing for the argument. So the full name, the full form for the pound sign is actually slot 1. So you can say, you can also have pound sign or number, we did that. Okay, so so this page is a complete detail about the Wolfram language syntax or the meta syntax or shortcut form. In Wolfram language, it's called input form, full form. You can read it and watch that video. Go hit the gym. I'm pretty fit, actually. So what is the next? Okay. So far so good. So far so good. Yes. Then we just need to compute this. Let's try it. We define the procedure and okay, incorrect, null. Oh, actually that's correct. You see, because this procedure fmove, it doesn't actually return anything because I put the semicolon. It doesn't return anything. Like I said, this is a procedural programming. While in functional programming, every function always returns something. You need input, output. Input, apply to a function to it, return the output, and use the output. That's how functional, that's the essence of functional programming. Doesn't matter, it's Lisp, Haskell, Wolfram language, Erlang, doesn't matter. What is the single most fundamental criteria for functional programming? That would be every computation is done by a function call where you take the input and you take the output, every computation, okay? If you don't do that, if you use, if your function do things with side effects, such as here, you are doing something, you don't care about the return value. For example, in JavaScript, often it's a case you take an array, then you dot for each. In Python, you also have that, or you use the for, for in range something. You don't actually care about output. You just want to do something in a loop. That's not functional programming, okay? So in the more pure a functional programming, the more less of that. So in Haskell, you don't have that at all. So anyway, so here is a functional procedure. But now we can check our stack to see if it changed anything. So our stack is here. So we just say the value of m, list of stacks. Let's see. Fantastic. CMZ, CMZNDP. Let's check if that answer is correct. Fantastic. Success. Okay. Solved the problem number, day 5, number 1. Okay, so the answer is, wait, let's modify this. We call that function, and the answer is actually just, we don't need actually. So it just modified the list of stacks. So that's not functional programming, which is not good. But because of this problem, it actually kind of requires procedural programming because that's what these instructions are. But can we do it in a functional way? Yes, by not setting things. So we don't want to do push and we don't want to do pop. Instead, when you do push or pop, you just want the function to return the new thing and work on that new thing. You never change your value of a variable. That's functional programming. Okay, but we already got lots of things on we need to implement efficient way to do push and pop of efficient stack data structure. So let's not worry too much about this now. Okay, so here is the solution. Now we want to solve the real problem. Okay, so the real input. So first of all, paste it here. Okay, and Control Shift N to make it pretty. So now we just need to change this part to the real input. Okay, let's get them. Pop this back and go to yesterday's talk show, search for input. So advanced code, so this is the input, 500 lines. Copy it, back to Wolfram, paste it. Okay, now press Shift Enter, we'll get the result. Oh, we forgot to suppress the output, so it's gonna be long. Okay, so here is the result. So what does it so here's the result. Close that. So but what does it need required result? So you just conjoin, you just join the string. So you need a list to string. Okay, so list to string is easy, so let's do it. Wolfram language. Okay, we want to is there a list to string? No. So what is the proper function? What you want is you know, a bunch of nested lists to a single string. So let's go look at string functions. If you are watching, say hi, okay? Tell me, how am I doing? Am I communicative? Am I doing good? List to string. So Wolfram language, very interesting. They have a kind of a strange function name. String rifle or string rifle. This basically, this function is list to string. So, and this function is actually new. So it is introduced in 2015. You know, I've been coding Wolfram language since 1993. So up to 2004, you know, I haven't been using it for like 15 years. But anyway, this function is introduced in 2015. Kind of strange name. Like I don't know what rifle means before. Rifle, a rocky shore or sandbar lying just below the surface of an ocean wave, a stretch of choppy water caused by such a shore or sandbar. A rapid, a wave or ripper in such water. Very strange. Why do they call it string rifle? You see, it creates a string by concatenating all the, you know, list, all the elements in a list with spaces insert between them. Okay, I don't want space. Okay, let's just do it then. So does anyone know why is it called string rifle? Let's see, there must be some, let me see, okay. It's digression, let's go to dictionary. This is my favorite dictionary. I'm very obsessive and picky about dictionary because I literally look up dictionary a few hundred times a day in the 90s, in the 1800s and 90s, literally few hundred times a day by a paper dictionary of this thick, Chinese, English to Chinese. So Then I switched to All English Dictionary, but the habit remained with me for like 30 years. Even today, I look up often. So I've looked, I literally read lots of dictionaries, like almost cover to cover. So I have particular taste and judgment on which one is better and so on. And let me just say the Merriam-Webster, which is most popular online today, that's the worst. Okay, that is the worst dictionary because it's what you see, the Merriam-Webster online dictionary, which is the most popular today, that came from Merriam-Webster's concise dictionary of English, or in other words, collegiate, also known as collegiate dictionary. So it's a abridged dictionary. So when you look up, with Merriam-Webster online, the definition are very terse, concise, abridged. In other words, that's a proper word. So oftentimes when you have a word you don't know, it does not properly give you the context, the nuances of the word. Anyway, I can tell you it's the worst, okay? Because and also they are also, for political reasons, they tends to be, they market. That's why they are the most popular. They market widely, aggressively. But it's the worst dictionary, okay? Merriam-Webster. But the full unabridged Merriam-Webster, if you actually buy it, it's like this thick, big book. That's good. Okay, that is good. Not the online, the concise or collegiate one. It's the worst. So if you have a knack on writing, on literature, on English, you want to do not read Merriam-Webster. It's the worst lousy one. What's the best one? American Heritage Dictionary. Okay, let me show you an article. So if you just go to xali.org, okay, then you have this section, Wordy English. Then you have this section, Dictionary Geeking. Okay, so I have 1, 2, 3, 4, more than 4. I have also an entire vocabulary, So anyway, there's 4 articles that reviews dictionaries. So if you read these pages in detail, you'll know why the Merriam-Webster is the worst one. Okay, you'll know. Okay, so go check them out. I give you lots of definitions, comparisons, and you. Okay, and by the way, there's also open source one. That's even worse. Okay, I mean all the Linux people, they get excited about dict.org. Lots of problems. Incompetent. Okay, that's a digression about dictionary. Yeah, so but what is riffle? Let's see. Games to shuffle, playing cards by holding part of a deck in each hand and raising up the edges before releasing them to fall alternatively in one stack. Oh, shuffle, yeah. You call it riffle, okay. Or to thumb through. So I don't get it, Usually the Wolfram language function names I very much agree on. But I don't get why joining string from a list is called riffle. Does anyone know? Yeah, I cannot see why is this called string riffle. Okay, but let's do it. So, okay, hold on a second. So we have the input. Okay. Run it. What is that? Yeah, okay, it just add empty lines. Why does it add empty lines? Oh, yeah, because you wanna say no separator. Oh, okay, so you actually need to so it actually refills. You see, when you have a nested list, it actually add the first one, followed by the first element of the second list, then the second element from the first one, then second, so they actually refills. Okay, so that's not what we want. So we want, let's see, DQ. Let's just try this, okay? Empty string. Maybe that'll work. That's what we want. Select it. Copy it. Are you sure? I think I'm pretty sure. Let's submit. Oh, well, it's got a string. So actually, copy that. Select or paste. Are you sure? Yes. Fuck. That's not the right answer. Fuck. I'm doing this because I have RSI. So too much typing for the past 10 or 30 years, in particular the past 10 years. What is the fuck? Oh wait, you just need the top one. That's obviously. You don't need all the stack. You just need the first element of each stack. Okay, of course. So let's pop this back, and in fact, let's delete that. Let's copy that, and let's work on our code again. So what you want to do is you have a list of stacks you want to map. Okay, map two arguments. The second, you want to apply a function. The first argument, a function to list of stacks, and the function will be just first. That takes the first item. Then you just do that. Okay. Then you just refill. Okay, so yeah, okay, so copy all, paste, run it. What? CMZ? Are you kidding me? Oh, I forgot the full input, not the example input. So some talk show yesterday, you want to get the input, so copy the input and put it here, run it, go down, oh god, oh god, oh god, oh god, there it is. Copy it, close, 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 go here. That's actually the answer. Submit. That is the right answer. You are 1 gold star. Okay, let's continue to part 2. So we talked for 80 minutes already. 70 minutes. Okay. Who is watching me? Are you still guys there? 5 people. 4. Say something. 5. Okay. Now, second problem should be easy. As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane. Some mud. And you quickly wipe it away. The crane isn't a crate mover 9000. It's a crate mover 9001. Now what is that? Is there an insider joke? So the crate mover 9001 is notable for many new and exciting features. Air conditioning, leather seats, blah, 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 blah. Fucking irrelevant fuck. An extra cup holder and the ability to pick up and move multiple crates at once. Okay, they are trying to change the move. They are fundamentally changing the way the stacks are moved. Okay, so again, considering the example above, the crates begin in the same configuration. Moving a single crate from stack 2 to 1 behaves the same as before. However, the action of moving 3 crates from stack 1 to stack 3 means that those 3 moved crates stay in the same order. I guessed I knew it's going to do that. Fucking idiot. Resulting in this new config, okay? Next, as both crates are moved from stack 2 to stack 1, they retain their order as well. Yeah. So now the crate can move more number of, the crane can move more number of items in one shot, so they don't reverse the order. Finally, a single crate is still moved from stack 1 to stack 2, but now it's crate C that gets moved. Yeah, okay. So in this example, the crate mover 9001 has put the crates in a totally different order, MCD. So before the reengineering process, updating your simulation so that the elves, the Santa, the reindeer, after the rearrangement procedure completes, what crates ends up on top of each stack. So all we have to do is to change this part, this function. Okay, let's do it. So this problem 1, okay. Let's go back, copy it, paste it. Now, let's do this again. Now, change this part, copy it, paste it, okay? Let's see. So P is not number of times anymore, so P is something else. Okay. Prepend list of stacks. So it's not do anymore. So let's remove the do. Okay, it's not do anymore. So this P is number of stacks to move in one shot. Oh, okay, so it's actually simpler. So number of stacks from M to N. So so you move P of number of them from M to N. Okay, so let's do that. So you move from M. So first, so you have a drop situation. Okay, actually, so you need to assign it. So you drop, but before you drop, you want to actually take the numbers. So you, instead of drop, you say take. Okay, you take the P items from stack M. That means returns the first P items. Oh wait, so you take from 1 to P. 1 to P. So let's check what is take. Let's look at the documentation. Let's turn on JavaScript. Okay, take the first N items. So you don't actually, you can just say P. Take the first P items. So wait, so because it's functional programming, so you need to so you take the first items, then you drop you take those items, P items, then you drop them. Yeah, and you assign them back to M. Then those newly taken items you need to add to N. So you need to prepend. That's right. So this line needs to go first. So the new N, stack N, one stack nanny. The new stack, the new stack nanny is going to be prepending the stack nanny by taking P items from stack mountain. Okay, so yeah, you take P number of items from stack mountain, prepend it to the stack nanny, and that will be the new stack value of nanny. Okay, then now you just need to drop the first P items in stack mountain. Okay, so you don't need this part anymore. So this is that is a function. Okay, now we can put a module. Okay, let's width. Okay, width is like a declare constant, except there's no constant. Basically, we just group them. And you can also group them by, and we don't need it. Okay, so this is the new function. Okay, so you don't need this. This is original. This is new. Now double check one more time. We're gonna run it one shot, and it's going to be correct. Right. Okay, remove that. Copy all. Back to Wolfram language. Paste. Run. Okay, so something wrong. Okay, something wrong here. PMN. Part, the expression M cannot be used as a part specification. I think I may know. Okay, let's try it again. Let's do this. And now let's do this. And I think maybe you need a paren. Okay, let's just copy all and do it again. Okay, now we run into this issue. When the stack is empty, there's no first item. So let's see. MCD is the answer. What? MCD is the answer, but we got CM, which is incorrect. Okay. Okay, so from stack M to N. Let's see what is our thing doing. Okay. Okay, let's apply the procedure is still the same. So 1 from 2 to 1. 1 from 2 to 1. So we got DNZ CMP. Okay, and now oh, that's right, you forgot something. I forgot something. Oh yeah, so because there is so that's about, we can easily solve it by just flatten. Okay, yeah, let's see, prepend. This is an issue that when you add several elements to a list, sometimes it's added as a sublist, sometimes it just ignore the list, it just add the elements. This happens in Python, in Perl, in other languages, in JavaScript. So you have to make sure, you know, depending on the function or the method, sometimes they flatten it, sometimes they don't. Very annoying problem. So here, yeah, so when you prepend elements, okay, you want to prepend elements, or you can use prepend tool. You see, they. Okay, I'm just going to do this. Okay, let's do this. Just going to say map to arguments, map that. This is gonna be a function. Map this function for each one. You know, this result is a list. This is very inefficient, by the way. So and in fact, you can say prepend too. So let's try this. Hold on a second. Let me clean this up so you can see better. So this is old code. The new code is gonna be here. So the new code is this prepend 2, okay? So you don't need that. So prepend 2, then that, okay? Here's a new code. I don't think that will work because the prepend tool, yeah, let's just say prepend. Okay, that should work. So here's a new one, and let's remove the old one. Okay. Wait a second. Yeah, this doesn't work. God, when you work with stacks, you really need a stack data structure. So if each one, yeah, so actually you need to actually put this inside. Yeah, that will work. You do that multiple times. Very inefficient. This is not the way to do Wolfram language, but let's just do it. Okay, right? We're getting tired. This is getting into it's incorrect again. Did we? Oh yeah, because we got the function wrong. Fuck, you need a paren. getting complex. This is not the right way to do it. But right now I just want the answer. CMZ. Shut the fuck up. MCD. Yeah, it's fucking wrong again. MCD. What? Okay, we need to think about this. Okay, let's clean up the code. You take those items. Oh, here you prepend, you actually reverse the order. Fucking idiotic. Yeah, you reverse the order when you do it this way. So you want to, yeah. I don't know if you guys know what I mean, but no questions, I'm just gonna code it. So you take this part, you want to prepend. Now, why, you see, this is not really suitable in Wolfram language, because you can see this prepend, they don't even take a argument. I mean, their second argument, which is, you know, usually every function in Wolfram language, when they take a list, they will just apply to every element of the list. But here, it's a single element. You know, there's no form where this second element can be a list. Why? The reason is because, well, it's a design issue. It's, you know, it's basically just because the Wolfram list is not suitable for this kind of thing. So what you want to do, basically right now you want to join. Yeah, join is the proper function. So you can see here is an example of join. Yeah, you don't want to use prepend, you want to join. So let's rewrite this function. That equals to join that and okay, so you take the first m items, I mean you take the first p number of items of stack mountain, then you prepend it to the stack nanny, then you assign that value to the stack n. Okay, so that is how we can do this. So let's remove these things we don't need. We don't need map anymore. Then the second part is just that. Okay, so we can do that. Okay, so that is our function. Copy all. Do it. MCD. MCD. That's the right answer. But let's fix something else, because sometimes when the stack is empty, you cannot call the first. Okay, so you want a function that takes the first element of a list. However, when the list is empty, you don't want it to return error. Okay, so how do you fix that? We can fix that by using pattern matching. But let's look at if there is some, if the Wolfram shows some solution, or if we we can do a if statement here, but that wouldn't be good. Yeah, let me show you. Okay, let me show you a technique, something interesting, a technique of pattern matching. So now the problem is that you want to take the first element of a bunch of lists, list of stacks. That's a list of lists. Each, that's a list of lists. So if there's no first element, don't return error. How do you do that? Okay, we can do it this way. So you start by that, and you want to apply this slash dot means replace all, and then you want to say a list first, okay, whatever. Then the second part is anything, we don't care, 1 or more, 0 or more, 3 low lines character. Okay, then replace it by replace it by just FST. So that will do that. Yeah. Actually, I'm not sure. It may return an empty list. Let's see. No comments? Anyone? No comments? So here, let's say result stack equals to list of stacks. Yeah, we need to, let's modify this so it doesn't actually change anything. Yeah, that's not okay. Don't do that. So you have a list, you want to get the first element, but if the list is empty, don't return any error. How do you do that? Easy. The simplest solution is to use an if statement. Okay, if length argument equals to 0, then what do? Yeah, return an empty list. Otherwise, first that thing. Okay, this is now a function, so you can just do it this way. That will return the result. Okay, now there are other ways, but I was going to show you pattern matching, but let's get the result. Let's get the answer for now. Okay, that's MCD. Okay, let's do this for the real input. Okay, let's do this for the real input. So open, copy. This is the real input. Copy, close. Okay, go back here, select that, paste. Okay, now let's add semicolon to suppress the long output. Suppress long output. Okay, do it. Yeah, forgot to suppress that one. Okay, so here is answer. Am I confident? Yeah, let's just do it. I'm pretty confident. Hello, Sam. Okay, yeah, shut up. Submit. Yeah, I'm confident. And let's just do it. Did we do it? Enter. That's the right answer. You are one gold star closer to collecting enough starfruit. Yeah. Okay, we finished day 5. Day 5 problem A and problem B. That's it for this video. Now I'm going to do a next video. Okay, so what time is it? It's 2 o'clock, so this is 2 hours. So I'm going to start the next video in 2 hours. So I can actually YouTube. So I'm going to start the next video in 2 hours. Okay, and that video is going to be, we are going to implement a linked list in Python, in JavaScript, and in Wolfram language, all 3. I'm gonna do it for sure. And we are going to test whether using the linked list as a stack data structure is more efficient than just using Python's default list. Okay, we are going to push a lot of items and pop a lot of items, and we'll see. Yeah, so in 2 hours, we're gonna do that. I'm going to create a video and I'm going to post it on XR Discord, and I'm gonna also announce it on XR on Twitter. Okay, that's it for today. So in about 2 hours, you'll see my announcement on Twitter and Discord. I'm gonna do another video, exploration of the efficient stack structure. Okay, in Python, JavaScript, and Wolfram language. So that's it for today. By the way, yesterday I did a poll on functional language Haskell versus OCaml. Okay, so you can see we did a poll, and that poll hit jackpot. That poll, here's the result. That poll has 937 votes, close to 1,000 votes. So it's rare for me. So, and I asked people to post their reason why OCaml or Haskell, and a lot experts of of Haskell or OCaml, they give their reasons. Very interesting. My own conclusion is I'm always I think maybe I'll pick up OCaml again. I did an OCaml study some 15 years ago. but I never actually went far. So I'm thinking maybe, because today maybe I'll do OCaml. I also did some Haskell, but never went far. Like I know Haskell and OCaml since 1997. So since 1997, back on news groups, there's a lot others. Today you guys don't know. Because for example, there's Miranda, which at the time Miranda in 1990s is the most popular commercial version of pure functional programming. Miranda and Clean. Okay, let me show you since I'm talking about this topic. Miranda language. Okay, back in 1990s, Miranda programming language is the most popular and most successful functional programming language, and it's commercial. Okay, it's commercial. It's not open source. This is 1990s, and this Miranda language is the main reason Haskell was created. Okay, because it's very popular commercial in 1990s. Remember, 1990s not like today because the CPU are not as fast. The RAM, the maximum RAM you can get is like 256 megabytes in 1991. 256 megabytes RAM, 1991. Okay, by year 2000 you might have 1 gigabyte. I forgot. But today it's like 6 gigabytes. And so anyway, so in 1990s, Miranda is very popular. Then Haskell is from a bunch of academics, programming language researchers. So they want a version, but Miranda is commercial. So, they are trying to create a version of functional language, So Miranda is very similar to Haskell. And there's also a very, very successful, popular Clean. Okay, a pure functional programming language, and this Clean programming language is based on term rewriting system, graph rewriting system. Okay, in 1990s, and it also supports lazy evaluation, just like Haskell. Okay, so these are all, these are at this time, around year 2000, Miranda and Clean, they are far more superior than Haskell. Okay, far more superior. Haskell even in 2010 is still kind of lousy. But time has changed. Microsoft began in 2003. They started F#. So anyway, so F#, that's the first commercial by a giant corporation that actually embraced functional programming. And we, functional programmer fanatics, we are like, oh my God, thank you, finally, the C and C++ Java idiots, they, finally they can see functional programming. Anyway, that's history. So I want to say, so Miranda, Clean, and OCaml. Okay, OCaml also. These three are the superior functional programming languages in 1990s, even back in 1990s. Now, today, Miranda kind of died. You never heard of, So, like in 2020, a version of Miranda was released as open source. It's kind of late, okay? It killed, here's another story about open source. Open source kill a lot of superior things. Open source and Free Software Foundation, they are a scum. When I was back in year 2000, I was a fanatic of Richard Stallman. And, I believe in his ethical qualities. In fact, between the war of open source and Free Software Foundation, I'm a fan of Free Software Foundation, just like Richard Stallman. I'm a fan of Richard Stallman, and I was waiting for his GNU Herd operating system. After 30 years, never came to be. Okay, GNU Herd. and Richard Stallman became this guru. When I was young, I believed in, like a lot of you guys, you know, and now I'm 50 something. I'm a few more years. I'm done for programming. So that's history. So I'm telling you guys my experience. So back in 90s, Miranda is the top quality functional programming, pure, okay, and clean. Also, clean is made in Netherlands, I think, Netherlands, something, Northern Europe, okay. Also commercial. And it also got killed by open source. What else open source killed? Open source killed BOS. Today you might heard of Haiku OS, okay. BOS got killed, got wiped out by open source. And Apple's lots of networking protocols, lots of things, okay. Anyway, BOS got killed by open source. Miranda got killed by open source. Clean got killed by open source. Clean in year 2000, they tried to, we are going to release a open source version. Too late. Too late. Miranda got killed by open source. Clean got killed by open source. Also, back then in 1990s, Erlang is another highly successful, superly used in commercial world, in commercial enterprise, Erlang. Okay, so Erlang about maybe 5 or 10 years ago, they also released as open source, but so luckily Erlang didn't get killed. Erlang is still a viable language, but so Miranda is kind of dead. Actually I need to read up what's up. What's their current status. Clean is kind of dead. Like 20 years ago, year 2000, I was so much, I so wish, and including Haskell, how they, I wish they become popular, but anyway. So Miranda, Clean, and OCaml, those are highly successful in late 1990s, okay. So anyway, I was saying, I did a poll, asking people about Haskell and where is it? Yeah, OCaml, and it turns out 1,000 votes and lots of experts, they gave their opinion. I don't have much opinion in either one of them. Of course I know them for 20 years, but I wrote Hello World, just a few, but never got into. So I'm thinking maybe I'll start to, between these two, I think I much favor OCaml. I don't like Haskell, okay, and I particularly despise the fad. These idiots, they don't know what they are saying. They don't know, young people. They think Haskell is a pure, lazy evaluation. Just like I was 20 years ago. When I see Haskell, lazy evaluation. This is the solution. This is the most elegant. This is the answer. We must use it. This is, theoretical, best thing. Lazy evaluation. Today you ask me, I don't think so. I don't think so. I don't want lazy evaluation. Okay. So anyway, I'm just saying my experiences. So maybe I'll try to pick up my OCaml, but I'm not sure because I'm getting old. There's a lot of things for me to do. I want to actually write a parser compiler, for example, the Emacs with tree-sitter. I want to dive into that. Possibly I'll create my own language or something like that. There's a differential geometry and lots of type proof systems, proof theory. I need to get into homotopy type theory. That I hope that I become somewhat an expert in that topic before I die. I don't have much time. 5 years or at max 10. I'm getting old. Type theory and lots of mathematics, differential geometry in particular, and proof, type theory, and mathematics, geometry, and so as far as programming language goes, well, I'm interested, but there's also Julia. I'm highly interested in Julia. Okay, so if you guys, young people, you want advice, I would recommend. So, OCaml, you can go into. It's very it's used in, by today. It's these both OCaml and Haskell are used in industry, not comparable to Golang, for example, or C or C sharp, C++. But however, they are fairly popular. You can get a job if you are truly good. Okay, so you can learn OCaml, or you can learn Haskell, you'll get a job, or you can learn Clojure. You will get a job if you are really good. Study. Okay, go study. Don't fuck around. Don't post memes or Rust. Like you read Hacker News, you just pick up, dribbles, then you post, Haskell is this way. No, don't do that. Like I did that for 10 years when I was younger. Try not to do that. Instead, master one language, do a project, do that for 1 year. So you actually really master, the language. Okay, not just, Rust support this, I know that, but you actually cannot code a project. Okay, code a project for 1 year. Okay, OCaml is good, Haskell is good. You can get a job in both and a Clojure. If you are really good, that's a key point. Okay, there are a lot. If you are really good. Okay, and then there is also Julia. Julia is a language, which I think they are also comparable, but I don't think there are many Julia jobs yet. Okay, so that's it for today. So again, in 2 hours or so, I'll post announcement. In 2 or 3 hours, I'll do another video on trying to implement a efficient data structure of stack in Python, in JavaScript, and in Wolfram language. Okay, thank you for watching. Go to my website, pay me. Okay, if you like, support. Go to my website. You'll see my PayPal and Patreon. Okay, thank you guys. Bye. Okay, there's an opinion. Well, I disagree. That's a